It's nice to be in Beijing. Lovely to see you all here today. That's gone out of, excuse me one moment. Right. Okay, hi. My name is Alex Danilo. I've been doing web standards with the W3C since 2002, so almost 15 years now. I'm currently editing the HTML 5.2 specification. I've done a lot of work with SVG and I'm playing around with WebAssembly, which is a really exciting new technology. But today I want to talk to you about HTTPS, which is also a very important technology when you're building progressive web apps. So one thing that we say when you're building progressive web apps is that they introduce a whole lot of new APIs, and these new APIs are extremely powerful. So with that new power comes great responsibility. It is your job to protect your users and protect your own sites from any kinds of problems. And I'll try to explain what I mean. So even older APIs like geolocation. Geolocation used to be available on HTTP, and now it is moving to HTTPS, because knowing where a user is a very powerful thing. For example, if you use geolocation on your site, you know if your user is at home or at work or almost anywhere, and that is a lot of knowledge that you have about the user. So this is why it's important to take care of that information. So I'll tell you a little story, and this is the story of the web. Imagine 25 years ago, a little scientist decided that he wanted to share his documents with his fellow colleagues. And so he wrote a little server and a little browser, and you could send documents to each other. So I could send you my document of my latest scientific discovery. This was a fantastic idea. And when I built that, if I was that man 25 years ago building that, I wouldn't care about HTTPS. I would just use the normal network and come up with a simple protocol, something I would call HTTP. And I would invent a language called HTML to display the documents. And my name is Tim Berners-Lee. That is actually what happened. But that was 25 years ago. And since then, the web has changed. It's moved from a document format to something we can build full, rich apps. And so in the old days, it was fine to just go and collect a document from the server and retrieve it because all the network was inside a very closed system. But fast forward to today, and all that traffic travels around the world between countries all over the place. And the fact is that anybody on the network between you and the server can see that traffic coming past. Now, when we were sharing documents, that was okay. But today, a lot of the internet is about e-commerce and money. So it's your responsibility to protect your revenue streams as website developers and also your users' credit card information. If I'm on public Wi-Fi or connecting to my internet service provider, if I send my credit card number over HTTP, anybody in between can see it. And this is a real problem. So this is what we need to protect. We need to protect the financial backbone of web commerce, and this is why HTTPS is crucial. So what we're really aiming to do is to try and get this little green icon up on our sites. And to get that to happen, there are 3 fundamental things that you need to do. Now, I'll just quickly explain what happens if you don't do this. If this was google.com and it was served over HTTP, I could be sitting in an airport connected to a public Wi-Fi spot, and somebody could put a big advertisement right here on top of my page saying, click here, download the new Chrome browser. And if I click that, it could take me to a site that downloads malware onto my laptop. And this is the risk with HTTP. But with HTTPS, this does not happen. And there are 3 things that it gives you. The first thing it gives you is identity, right? With HTTPS, what happens is a digital certificate is sent between the server and the client. What that certificate does is it guarantees that if I connect to google.com or google.cn, I am talking to that server and not another server that is impersonating that site. So it's very important, so it guarantees you are connecting to the server you attempted to connect to. The second thing it gives you is confidentiality. What that means is nobody can read the data transferred between the server and the browser. So in the case where we were exchanging credit card numbers, no one can see my credit card number and then use it to buy things on Alibaba. This is very important. And the third thing it gives me is integrity of data. And what that means is no one modified the data between the server and the browser. So the only two parties that can change the data that we exchange are the server and the browser itself. So these are three fundamental pieces that you get with HTTPS. Okay, but a lot of people wondered about the performance impact, the cost of actually implementing HTTPS, and the maintenance burden. Now, of course, as developers, if you're building sites or serving sites, you want it to be fast, so you worry about performance. You don't want to spend a lot of money, or you don't want to burn money for no reason, so cost is important. And maintenance is another issue. It means you have to get these certificates, you have to manage them, you have to work with them. So let's just dive into this a little bit more. So let's take a look at a few of the criticisms that people have levied against HTTPS. One is that, you know, my site doesn't really need it. Do you really need it? I mean, all my site does is show a few photos that I've taken on my holidays. Is that really necessary to use it? The other thing is, it'll cause performance problems, and I'll lose money because if my site slows down, people will run away and they won't buy the e-commerce things that I have for sale. The other thing is, it costs a lot to implement, and third-party sites won't necessarily support it, so why should I bother? So let's just dive into them one by one. What we think is that HTTPS is the minimum foundation of building a modern website today, or a modern web app. It's something you really need to do, because even if you think your site doesn't need it, if you go, as I said before, to a public Wi-Fi hotspot and connect to your simple site that just shows pictures, there is nothing stopping that site popping up an ad over the top of the picture saying, "Click me." I personally have connected HTTP sites on my phone at airports, and suddenly I have a pop-up that says, "Your Android device is infected with malware. Click here to wipe your device." Has anyone experienced anything like that in this room? Yes. Yes, a few people. Right. So that is the risk using HTTP. So one of the other seriously important aspects of this is all of these fantastic new APIs that give you the progressive web app experience. Not even just progressive web apps, but any modern site. These require HTTPS. Not all of them here now, but some people may still use app cache and encrypted media extensions. Now, both of those APIs currently work without HTTPS, but they are being migrated to HTTPS as an extra security measure, because app cache is a perfect example where I can intercept the traffic and store the wrong data into my app cache. So that is moving to HTTPS. Same with encrypted media extensions. So if you currently use these two APIs, please make a migration plan and move off HTTP and onto HTTPS. Okay, we've just heard Pete give us a lovely explanation about what service workers are and why they are so useful to you. Now, the thing is that service workers will only work on an HTTPS connection. You must have HTTPS or service worker will fail to run at all. Now, the reason for this is that the service worker is the thing that jumps between the browser and the network. So it has a massive, massive exposure to the data that comes between the browser and the server. So it must be encrypted. This is purely for protection of your users, of course. So now, what do we say here? So the point about this slide is basically HTTPS is no longer considered something that is only needed for security sensitive sites. We've seen ad injections, all sorts of strange things that go on in the public internet, and it's very important for your users to give them a proper user experience, because if you're running an e-commerce site, you want all the money to come to you. If you're hosting some kind of information and you use advertising to monetize that, you don't want your users to suddenly be served different ads and the money to go somebody else. So what about the performance issues? One of the things that people talk about is it'll cause performance problems and I'll lose money. So this might have been true 5 to 10 years ago, but all the browser vendors and the entire internet infrastructure has changed over the years, and it's no longer a real problem. So I'll tell you what's happened in the past few years. So when you set up a HTTPS session, what happens is that normally you connect on HTTP. Say if your server is serving HTTPS only, and somebody attempts to connect with an HTTP address, there are 3 round trips. What happens is that you connect with HTTP, the server says, sorry, here's a 301 redirect, we actually want you to serve over HTTPS, and then you have to go back and forth to the server 2 more times to do a TLS handshake to set up the HTTPS session. You can shorten that very easily by using strict transport security, HSTS. And so what this is a header that you return from your server to the browser that says, in the future, if you ever ask for HTTP, we will just, please ask for HTTPS instead. So in this example, I'm saying, for the next month, if anybody types HTTP into my domain, automatically issue an HTTPS attempt to connect. Right, so if I have, http://google.cn, and this comes back in the first response, then in the future, if the user types http://google.cn into the browser and hits return, the browser will intercept it and go, no, it should be HTTPS, and start the TLS handshake immediately, which saves a full round trip. So this is basically, that's the written version if you didn't understand how I was speaking, because I do have an Australian accent, which can be difficult to understand, even for me. Okay, so, oh, there. This keeps jumping out of. Sorry. Yeah. Okay, so here is a typical handshake. So this is what I was talking about before. The original HTTP request goes out, the 301 redirect comes back, then we start doing the TLS handshake. So there are 3 full round trips until we can issue the first GET request to get our first resource. So it's a lot of slowdown, but there are ways to speed this up. This is the actual TLS handshake itself. And so one of the things that you see here is that it goes out, comes back with a certificate, says, okay, it's finished, waits for the response, and then issues the GET request. But what we can actually do on the client side is change the order by issuing the GET request before the third finished has come back. And so this will actually speed up our response time, and we call this TLS false start. So we're actually starting the GET request before we've acknowledged that we've finished the handshake. And that is an option that you can turn on your server, and I encourage you to do so. Now, another thing is that when we start the first TLS handshake, we can use a session ID. So this session ID is something we can issue. So with the first request to set up the TLS handshake, we send a session ID. And what that does is that in the future, when we start to do another request, we can actually use what is called TLS session resumption, which will also get rid of the extra finished, takes off one of the round trips. So that also speeds things up. This is also something you should turn on your servers. Okay, now, another incredibly important thing is that HTTPS is required for HTTP2. Does anybody know what HTTP2 is in the room? A few people, great. Well, HTTP2 is the next generation of transport protocol for web browsers. And 2 of its main features are multiplexing and server push. Multiplexing means that you can get multiple assets on a single TCP IP connection. So instead of using one socket for one resource at the same time, I can be fetching 3 or 4 or 10 or 100 resources on the one TCP connection. And the browser and the server negotiate how that works. Server push is a completely different thing. Server push means that the server can send assets to the browser before the browser asks for them. So For example, if I ask for an HTML page that contains a lot of images, the server can start sending the HTML page back, and the server knows that the next thing I will do is ask for all the images on the page. So the server can begin sending the images back to the browser even before I ask for them. And this is a feature of HTTP2, and the reason it's there is to speed up loading of websites. However, HTTP2 requires HTTPS, so it runs on top of HTTPS. One of the reasons that is that there is a lot of infrastructure already around the world for the web. There are a lot of gateways that all understand HTTP 1.0 and 1.1. All of those gateways can do things with the traffic, right? They could change things, they could do compression on the fly, they can make all sorts of different changes. And because of the existing infrastructure, it's impossible to deploy HTTP2 without sending it over HTTPS, which provides an end-to-end connection with no integrity violation. Remember, we talked about integrity? So HTTPS means the server data is exactly what ends up at the client, and that's why HTTPS needs to be the transport medium for HTTP2. Okay, so here is an example of a site called weather.com who actually made the transition from an HTTP site to an HTTPS site and HTTP2 at the same time. Due to their architecture, when they first jumped to HTTPS, they saw a 50 millisecond slowdown because of the way their site was constructed. However, this was part of a larger plan to shift to HTTP2, and when they deployed the HTTP2 version, they saw a 250 millisecond per page view reduction in time, in latency. So they saved 1/4 of a second on a page by switching to an HTTPS connection with HTTP2 traffic on top of it. So from a performance point of view, you can actually get a win if you shift to this kind of model. Okay, but what about the expense? I mean, you know, what happens with a HTTPS connection is that the server and the client communicate using digital certificates, and you have to obtain a certificate. And historically, this has been a very expensive thing, and so people don't want to spend the money to do this kind of thing, or the cost of implementing, I mean, developer time, etc. So buying a certificate was costly. The other concern with HTTPS that I've heard is search ranking. So if you tell a search engine I have an HTTP version of my site and an HTTPS version of my site, people sometimes think that means because half your traffic's going to each site, that your search ranking will drop. This is not quite true, and I'll just walk you through a couple of things. So let's start with certificates. Has anyone bought a certificate for HTTPS recently? Oh, at least a couple of people. Okay, well, we know of this project that's an external project over, I'm not exactly sure where it's hosted, but they sell certificates for $16 a year, 16 US dollars, that's about 110 won. Right, so it's not a lot of money. And in fact, if you host a multi-site site, they'll sell it for about 170 won. So it's not actually a large expense when you're paying developers to write code. Then there's another project that started relatively recently called Let's Encrypt. And this project provides you certificates for free, so that don't cost you anything. Now this is a great way to avoid having to spend money on this, and so that really takes away any problem of cost. Now, we should go into the search ranking. Now, search ranking is an interesting one. You, of course, don't want to go down in search ranking. Everybody's trying to get up to the top as much as possible. So if you migrate your site from HTTP to HTTPS, there are a few best practices that you can use that search engines will understand. So one of the first things is if you issue this HTTP 301 direct, like so somebody says, HTTP, go and get this. The server says, no, 301 redirect. If you actually put in moved permanently the new location, then from that point on, the browser knows for the meantime that it should go there, but search engines are smart enough to remember this too. And so search engines will go, the HTTP site is no longer there. We will refer to the HTTPS site as the correct site. And then on top of that, inside your content, when you serve it on HTTPS, you need to put in this link, rel equals canonical. Now this tells the search engine that this is the definitive version of your site, right? So the HTTPS version is canonical, which means whenever you want to refer to that for search ranking or anything like that, that is the site and not the HTTP. Okay, so as far as working out what to do with as search engines and stuff, we've put together a whole lot of guidance. So if you actually go to this site, you can walk through it and find a whole lot of guidance on best practices to make sure that your search engine ranking remains high when you make the migration from HTTP to HTTPS. It's a very good thing to do. Okay, so finally, the last point on all of this is that if you have a site that pulls together content from a bunch of third-party sites, like ads, or images from an image server, or content from a CDN, then you have to worry about whether or not those sites support HTTPS as well. Because to get the full green icon, all your content on the page needs to be served on HTTPS. Now, one of the most important things that we put on our websites are ads. And so, of course, there was a kind of survey done by the IAB. The IAB is an internet advertising kind of oversight committee that has a lot of the ad-serving networks as members. So as far back as 2013, so 3 years ago, they noted that a lot of their members, 80%, had already completely shifted to HTTPS, and the plan was to have 100% compliance very soon. So as far as ad serving goes, that's already well and truly on its way, and we'll wait to see when they finally hit the 100%. Now, if you are a developer and you're working with HTTPS and you're trying to debug on your site, you can also pull up Chrome DevTools. So Pete showed you Chrome DevTools, which had the wonderful stuff in there for service workers. So inside Chrome DevTools, we actually have a whole lot of HTTPS stuff, and this is showing you can look at the certificates, you can look whether the site has mixed content, which means some secure and some insecure, and it will show you a whole lot of stuff that you can debug with. It'll put out console log warnings. So as a developer, when you're trying to debug your site and you don't know why you haven't got the green lock, the Chrome developer tools will help you, and I'm sure all the other browsers pretty much have this. So what's next? We have basically a whole lot of stuff that you can look at on the developers.google.cn website. So encrypting data in transit, which just kind of explains how this all works. Using content security policy. Does anyone know about content security policy in here? Put up your hands if you know what CORS is. Excellent. I would highly recommend people read this because this is very important. Content security policy is a way of enforcing loading from third domains, like other domains than your own. And one of the nice things you can do with the content security policy stuff is if you have a site that is migrating, on your server you can add a header that will give you a warning in the console whenever you try and load non-encrypted content. So things like this, there are some very good practices that you can follow in there, and guidelines for preventing mixed content. So anyway, I have a nice short talk for you today, and I would just highly recommend you all switch to HTTPS because, you know, as I said at the beginning, I'll just reinforce it. The days of e-commerce on the web are here today, and it's huge, and it's up to you to protect your users, protect the money that they're paying to you for services, and also protect your own revenue streams when you're running sites. So, and if you want to build a progressive web app with Service Worker, it's required. So anyway, thanks for listening to me today, and hope you learned something.
看在场的有什么问题 ？Alex 这边对 Alex 这刚才讲的一套，有现场提问的吗？
You said the searching ranking rule is the common rule for almost the searcher like Baidu or Bing. This is the common rule recommend to use the link the HTTPS domain .com.
Yes. That was the question of whether using the link rel equals canonical is the right way for search engines such as Baidu and Bing, etc. Yes, this is common knowledge for all the search engines, so that's the best practices so that the algorithms that generate the searching database understand that that is the definitive version of your site, especially if you have a site that you're migrating, like say that you already had a site that was on HTTP, and it has a ranking. So that ranking is stored against the URL with the HTTP on the front. As soon as you do the redirect and then put the link rel equals canonical, then the search engine will assign all the weights of the ranking to the HTTPS site.
Got it. Thank you.
May I ask you some tips for mobile developer, like at Pinner? It works for at Pinners, or make the server notify our certificates owner. It doesn't work for HTTPS.
Can you repeat the question, please? Sorry.
Okay. I want to add Pinner in my mobile apps for HTTPS. Pinner. Pinning.
A pin or?
Pinning.
Oh, pinning.
Yeah. It works for HTTPS. It works for HTTPS.
I'm not actually sure of the answer to that, sorry.
I think he's asking your opinion about like mobile development on using HTTPS. Maybe some tips, maybe some like extra suggestions.
Tips. My opinion.
Yeah.
Well, HTTPS is for mobile is basically very little cost in terms of performance, battery life, and things like that. A long time ago, 5 years ago, that was not the case, but now in a modern browser, the CPU load for using HTTPS is like less than 1% over HTTP. It's a very low computational cost. And as far as performance, latency is, once the connection is set up, it's exactly the same as HTTP. If you shift to HTTP2, you will see lower latency and higher performance.
Oh, thanks a lot.
是这样的，就是之前的话，我在做安卓的一个 HTTPS 优化时间，就是说我做了很多关于3人 cache， 还有一些 HSTS、KP 一些相关事情。但是我发现，在移动端的话，效果不是很明显。就是说，因为很多事情的话，它是和浏览器进行一个交互的一个缓存的一个东西。我不知道，就是在我升级 HTTP2 之前，它那个优化不是很明显。我不知道在就是不升级 HTTP2 的情况下，我移动端的话优化的话，就是对于 HTTPS 的访问优化的话，有什么建议没有？
Okay, let me do a translation. So you just mentioned like HTTPS together with HTTP2 give a performance boost on mobile development. But the question here is that for Android development, if we don't account for HTTPS, well, HTTP2, what would be your suggestion about HTTPS in mobile development? Because like that seems to incur a performance hit.
Very good question. In general, the performance hit is very low. The weather.com example, their performance hit that they took was due to the architecture of their application, not HTTPS itself. So basically the only cost is in the initial setup, if there is any cost. And so if you do the permanent redirect and the TLS false start, you will reduce the round tripping, and so the performance cost is almost negligible. You wouldn't even notice it.
还有一个问题就是，刚才我看到就是他之前说有一些就是开源的关于证书的一些项目，但是我们选择 HTTPS 证书的时候，我们通常会考虑 CA 厂商的一个安全性。我不知道他是如何能保证我那些，你比方我们平常选择 CA 证书的话，一般就是三门铁克或者是 GoDaddy， 但是就是它开源的这些是如何保证它的一个 CA 厂商的一个安全性的这方面的事情。因为我们知道之前欧洲发生过同样的事情，就是说 CA 厂商被黑客攻击了，然后所有证书泄露这种。
I think the question is, for developer to get the certificate, security always the first concern. And you just mentioned like two wonderful places to get the certificate. Now the question is, he's wondering like how security, what was guaranteed for security for those sites, as they are open source, which I'm not sure if it's correct. So what's your opinion on that?
Okay. Well, firstly, to get the certificate issued, you have to prove who you are. Okay, so they are just a certificate issuing authority. So you have to first prove to them that you own the domain, etc. Those certificates are signed by a central authority, and so there is no problem as far as their authenticity. But one thing that I did forget to mention, which I should mention, with both those things, SSL-Mate and Let's Encrypt, they also provide command line tools which let you update, maintain your certificates so that they will never expire. So they handle all the automatic updating when the certificates expire. And so by using their tools, it basically takes the development burden down to zero once you've started using them, that is.
So basically, you're saying they're safe to use those two websites to get a certificate?
Yes, absolutely. Yep.
I have heard that we can use HTTPS to defend the man in the middle attack, but when I try to attack my myself website, I changed it from HTTP to HTTPS. I successed. What's the right way to use HTTPS to defend the man in the middle attack?
All right. What's the best way to use HTTPS to prevent a man-in-the-middle attack?
Yeah.
When you attacked your own website, did you use a self-signed certificate or a certificate from an authority?
I installed a software in my server, and try to pull requests to my self website in the by use the browser, and then I try to我去用中文说吧，不太好描述。就是说，因为我们学校就是局域网嘛，然后我发起攻击的机器和我的那个就是机器在同一个局域网里面，然后我试图 ARP 攻击截获了他的那个请求，然后就是那个什么截获他的请求，然后拿到了东西虽然是加密的，然后就是拿到东西虽然是加密的，但是还是拿到了一些东西的，然后那个，并且我能够成功阻止我的客户端获得，就是成功阻止我客户端获得我服务器发回的数据，可以直接让它得到404。我怀疑是不是因为我客户端没有验证我自己的证书，还是因为一些什么其他的原因？就是正确的使用 HTTPS 防止那个中间人攻击的完整流程是什么？应该都在哪些环节验证哪些东西？I'm
trying my best. Okay.
Okay, I can try it. I think since I have the microphone, so I was listening. So I think the audience is asking a debugging question. He was trying to set up a hacker machine, trying to hack his own domain using HTTPS, and he found some issues that his hacking machine in the same local network can actually intercept the response from server and return a 404 to the client, and then the client actually get the 404. I mean, the intercepted content itself is encrypted, but since he still be able to manipulate the server response in some way.
Yeah, okay. If you're on a local network, if you're going through a proxy or if you're going through anything, there is nothing that HTTPS can do to stop you breaking the network. You can cut through the network by doing almost anything. But if you are trying to set up an HTTPS session, the first thing that goes out is the domain that you're trying to connect to, right? And the certificate that comes back from the server to the client is signed with that domain. So even if you can block the request going out, you should never get a response back. Like if you're doing it on your own local network, like there are exceptions. For example, when you're debugging service worker on the local network on localhost 127.0.0.1, you can actually use a service worker without HTTPS. You can use HTTP localhost because it's the local trusted network and the client understands that. But you should never be able to have the connection from the server back to the client blocked unless that certificate is valid, right? So if you successfully set up an HTTPS connection to your server that you were trying to hack, you would have had to have served the certificate which validates the domain that you were trying to connect to.
那也就是说，我理解下来，那个 HTTPS 并不能。然后我也有尝试过，对我加了就是更改了那个协议，变成 HTTPS 的我自己的网站进行 DNS 污染，然后发现也成功了。就是我成功的把那个一个 HTTPS 后面的域名，然后重新定向到了我自己写的一个东西上，并且我写那个东西好像不是 HTTPS， 就是那个我自己在另外一台机上起了一个服务嘛，然后把重新向另外一个 IP 上，它通过一个域名拿到了错误的内容，然后这里浏览器只是验证我证书是没有经过认证的，就是在那个浏览器的那个域名的前面那个 HTTPS 里有个叉号，但是我这边还是成功的把它污染掉了，也就是说 HTTPS 是不能防止这些内容的，是吗？
Okay, I think he's still following up the question, and I think maybe I should correct the previous translation. He was not from the local machine; it's from the same LAN. It's like in the same LAN network. You're sharing probably the same set of the IP, but that doesn't matter. So his following up question is, he somehow continued to hack using DNS pollution and still manipulate it some way, but I think it's very specific, which I'm not sure I get it right. So maybe you guys can.
Well, I think what we should do is talk after you can come over here and talk to me after the talk, because this will go on for a long time and you can explain in more detail. Okay?
Hi, sir. If we apply HTTPS into our website, the government cannot see the data during connection. So do you think the authorities are more likely to block the web spirit of the use of free certificates in the future?
I honestly don't know the answer to that. I think that it's basically impossible to tell the difference in the certificate itself, because that goes over the encrypted connection anyway. Because the certificate is signed, because what happens that's basically like a public-private key setup where the browser is sending a public key, the certificate gets encrypted, and it comes back encrypted. So there is no way to know the issuer until it decrypts on the client anyway. So that is not something that's detectable. So the data is not visible. So because the connection is from the client to the server and encrypted in both directions, so the visibility of the certificate authority is nowhere to be seen until it decrypts it on the client in the browser. So it should be no different to any other certificate.
我想问一下，就是我们 how to debug， 就是特别是那个 binary 的数据，还有一个就是 HTTP2 或者是web 就是 WebSockets， 就是 how to debug。
How to debug the HTTPS connection or the handshake?
He was asking how to debug a binary data like WebSocket and things like that. I mean, using HTTPS, like if it's transporting binary data, I'm not sure.
So it's hard to debug binary data, including the WebSocket and some other things.
Right. You mean for like watching it to try and work out what's going back and forth across the WebSocket?
Right. What kind of tool we can use to debug, say, binary data? over HTTPS?
Or encrypted data? Well, that's a very hard question. If you're talking about when you're developing your site, if you want to debug what's going across the WebSocket, I would. It's a very hard question. I'm not sure of the answer to that, to be honest. But maybe you can describe your scenario to me after the talk, and we can talk through it, because right now I can't think of an answer. So.
Okay, one more question.
那我问一下，就是说 HTTPS 它实际上是基于一个根证书，就如果我设备上的根证书已经被替换成一个恶意的证书的话，我怎么避免就是说我识别到一个恶意的证书，也把它当成一个合法的证书的情况呢？
Okay, so the whole HTTP story is based on the certificate. What happened if the local copy of the certificate was replaced by a malicious copy?
Then you're in bad trouble. Yeah, that's a very good, very, very good question. The certificates, because of the way that they're encoded, I mean, they remain encrypted on the device. So basically, if you have some kind of malware thing that compromises a certificate, yes, there could be problems. But again, this is kind of beyond my expertise in cryptography. I know that there have been a number of accidental collision attacks where people have been able to generate certificates that have the same hash as another certificate. And what we've done in the browser community is tried to deprecate and get rid of insecure cryptographic algorithms. So for example, SHA-1, which was used for certificates, is something that is no longer supported in browsers. So Firefox, Edge, Chrome all don't honor that certificate because it's something that we know can be broken. So browsers have moved to more secure cryptographic algorithms. And so the chances of impersonating a valid certificate are very, very low, because those impersonations, to replace a certificate with another one that impersonates, means that you have to have a collision in the cryptographic hash, which is very, very difficult to do. So when we've identified weaker encryptions, they've been removed from the browsers. And so you will get the red bad certificate icon on the address bar if that happens.
Okay, thanks, Alex.
Okay. Thank you, everybody.